We look at rivers all the time, but we tend to see them as just water flowing from A to B, but they're so much more than that. They are, quite literally, the master architects of our planet. So today, we're going to trace the incredible life story of a river, from a tiny mountain trickle to a huge, powerful force, to see exactly how it carves, shapes, and actually builds the world around us.
I mean, have you ever really stopped to think about it? How can a simple stream of water carve out a valley that's miles wide? It seems impossible. Well, the answer is a fascinating story of power, time, and geology. We're going to follow a river's life, from its high-energy youth to its wide, gentle old age, to see exactly how it works its magic, one grain of sand at a time.
So, to really understand how a river does all this work, we first need to look inside its toolkit. And just like any master craftsperson, a river has a very specific set of tools for both carving away and building up the landscape. Okay, first up are its demolition tools, the ways a river erodes. You've got hydraulic action, which is just the sheer force of the water getting into cracks, compressing the air, and blasting the rock apart. Then there's abrasion. This is where the river uses the rocks and sand it's already carrying, like sandpaper, just grinding away at its own bed and banks. It's even got a chemical tool, solution, which can literally dissolve certain rocks like limestone. And in the craziest, most turbulent water, you get cavitation, where tiny air bubbles collapse with so much force they create shockwaves that shatter rock. Wild, right? But once the river has ripped up all this material, it doesn't just leave it there. It's got to move it. The biggest, heaviest boulders just get rolled along the bottom. That's called traction. Smaller pebbles and gravel kind of bounce and skip along in a process called saltation. The really fine stuff, like silt and clay, just gets held up in the water itself. That's suspension, and it's what gives a lot of rivers that muddy color. And of course, all that dissolved rock is carried along invisibly in solution. All right, with our toolkit understood, let's start our journey. We're heading way up into the mountains, into the river's upper course. This is where the river is young, it's fast, and it is just brimming with raw energy, all thanks to that super steep downward slope. At this early stage in its life, the river has one primary mission: cut straight down. This is called vertical erosion. That steep slope gives the water so much power that it focuses all those tools we just talked about downwards, like a powerful saw cutting deep into the earth. This relentless downward curving is what creates those classic steep, V-shaped valleys you see up in the mountains. And one of the most spectacular things you'll find here is a waterfall. The way it forms is a perfect example of these processes in action. It all starts when a river flows over a layer of really tough rock that happens to be sitting on top of a weaker, softer rock. The river just eats away at that soft rock way faster, creating a big plunge pool at the bottom and undercutting the hard rock ledge. Sooner or later, that overhang has no support and it collapses. The waterfall then effectively takes a step backward, and this process just repeats and repeats, slowly carving out a stunning, steep-sided gorge as it retreats upstream over thousands of years. So, as the river leaves the mountains, the land starts to level out. Now we're in the middle course. Here, the river slows down a bit, it starts to mature, and its whole focus shifts. It's no longer about cutting down. Now it's all about carving sideways and making its valley wider. Now, to understand what happens next, we need to talk about the Thalweg. It sounds complicated, but it's really simple. It's just the line of the fastest flowing water in the river. Think of it like the river's main current, its own personal express lane. And naturally, that's where the most erosive power is concentrated. Okay, so as this fast-moving Thalweg swings from one side of the channel to the other, it creates this amazing corkscrew motion in the water. It's called heliquidal flow. This spiraling current is the absolute secret ingredient for one of the river's most iconic and beautiful creations. You've definitely seen them. Those beautiful, winding curves in a river are called meanders, and they are anything but random. Here's what happens. The Thalweg, that express lane of water, slams into the outer bank of a bend. This causes a ton of erosion, carving out a steep little river cliff. Meanwhile, that corkscrewing helicoidal flow acts like a conveyor belt, sweeping the eroded material across the riverbed. It then drops it all on the slower inner side of the bend, building up a gentle sloping beach called a point bar. It's this perfect self-reinforcing system: erosion on the outside, deposition on the inside. But wait, not all rivers meander. Under different conditions, specifically if a river is carrying a massive amount of sediment and has really weak banks, it can form a totally different pattern. Instead of one main channel, it splits into tons of smaller, shifting channels that weave around these little islands of sediment.
This is called a braided river. You see these a lot near melting glaciers, which dump huge fluctuating loads of sand and gravel into the water. All right, we've now arrived at the river's final stage, the lower course. The river is wide now, it's slow, and it's getting close to the end of its long journey. Its primary job isn't really erosion anymore. Now it's all about deposition, dropping that huge load of sediment it's been carrying all the way from the mountains. This stage also brings us the final act in a meander's life. As those curves get more and more exaggerated, the little neck of land between two bends gets narrower and narrower. Eventually, during a big flood, the river decides to take a shortcut. It just smashes straight across that narrow neck, creating a new, straighter path. Over time, sediment builds up and seals off the old loop, leaving behind this beautiful crescent-shaped lake called an oxbow lake. This whole wide, flat valley you see in the lower course is called a floodplain, and it was built entirely by the river itself. Every time there's a flood, the river overflows its banks, it slows right down, and drops layers of fine, super fertile silt all over the valley floor. And as it floods, it drops the heaviest sediment first, right at the edge of the channel, building up these natural embankments called levees over time. So what about all that sediment? I mean, every single grain of sand and silt the river has carried on its incredibly long journey has to end up somewhere, right? Well, that final destination, the grand finale, is the delta, a massive new piece of land built right at the mouth of the river. This process is just amazing because the river literally builds new land. As the river flows into the still water of a lake or the ocean, its speed just plummets, it slams on the brakes, and it's forced to drop its entire sediment load. This deposition clogs up the main channel, forcing the river to split into a whole network of smaller channels called distributaries. And over centuries, this process builds the delta outwards, further and further into the sea, creating these vast, flat, and incredibly vital ecosystems. So there you have it. From a single drop of rain high in the mountains to a mighty delta building new land out into the sea, the river's journey is this incredible, powerful story of geological creation. It's constantly carving, carrying, and constructing our world. Which leaves us with a final, really important question to think about. If rivers are the architects of our landscapes, what happens to that delicate balance when we decide to change the river? Thanks for joining us.